Hello and welcome. In today's video, the article that we'll be discussing today is titled Modifying the Diet and Gut Microbiota to Prevent and Manage Neurodegenerative Diseases. This article was written by Ellen J. Gates, Anna Cabernath, and Andis Clergis, and it was published in 2022. The journal is Degrada Brill. So I will touch a little bit on the abstract. And what I want to just take note is the last sentence, which states that the translational potential of such research is illustrated by the clinical success of a recently developed Alzheimer's drug, GV971, which is a seaweed derivative that works by modulating the gut microbiota brain axis, which is kind of the reason why we are interested in examining this as a potential treatment for Alzheimer's disease. However, this paper does touch on Alzheimer's and Parkinson's disease to be more specific. And the foods and fermented foods and fruits that are going to be talked about are grapes, pomegranates, seaweed, and a fermented food known as kefir, which is usually a yogurt. Just a little bit on the introduction here. Due to the rapidly aging wildlife population, neurodegenerative disease has gradually increased over the past few decades, reaching epidemic levels. Many advances have been made to understand the complex mechanism underlying their pathogenesis. And if you don't really understand how Alzheimer's disease happens, there's a lot of videos that I have before these that can kind of explain that in detail. Preferably the first video, which kind of explains exactly what Alzheimer's disease is, and Parkinson's disease remain incurable. Identify novel approaches to prevent the onset, ameliorate symptoms, and delay the progression of AD and PD is imperative to improve the quality of life. So we know that recent evidence has basically told us that the gut microbiota having a so basically modify such as limiting meat and dairy consumption and increasing the intake of fruits, vegetables, as well as fermented foods have been shown to shift gut microbiota to a healthy enterotype. What is enterotype? So enterotype is basically, think of it as population. So you want to have a good population of bacteria versus a bad population, because a good population is going to prevent diseases such as cancer, cardiovascular disease, and type 2 diabetes mellitus. And that's what we want to be looking at. So regardless of ethnicity and geographic location, healthy gut microbiota have the highest abundance of the phyla Firmicutes. These are the important ones: Bacterocetes, phyla Actinobacteria, Proteobacteria, and phyla means family. So we have the family of Actinobacteria and Proteobacteria, which is in great abundance. Actinobacteria, specifically Bifidobacterium, which is really healthy, are often found in probiotics and play an important role in maintaining a healthy gut. So you want to be looking at Bifidobacterium when you're looking at the family of Actinobacteria. And if you don't have Actinobacteria, you can look at Firmicutes Bacteroidetes, which are also known to be good as well. So I think I talked a lot about what Alzheimer's disease is, and just to touch on a little bit, Alzheimer's disease is basically known as the accumulation of amyloid beta protein inside the brain, as well as neurofibrillary tangles, which are found within the brain, and these kind of cause cascading effects that lead to aberrant neuronal formations, as well as death of neurons, and further a lot of inflammation within the brain, causing further degeneration of the neurons. But what's Parkinson's disease? So Parkinson's disease is basically known as the death of dopaminergic neurons within the region of the brain called the substantia nigra, more specifically substantia nigra pars convecta, and it is basically known that it is the development of Lewy bodies, which is basically like aggregates of a type of protein known as alpha-synuclein. And PD patients presents with motor symptoms, tremors, bradykinesia, meaning slow movement, and non-motor symptoms, including gastrointestinal issues and olfactory dysfunction, as well as they tend to have mood disturbances as well. So just jumping gears, we're going to go ahead and just talk about, I'm going to show the study that or the paper, the presentation that I have here ready. So gut-brain balance and how good gut health may help prevent neurodegenerative disease. So earlier, I wanted to just kind of touch on the more specific bacteria that you want to be focused on, and that is actinobacteria. And within actinobacteria, you're looking at bifidobacteria. The good bacteria are actinobacteria and proteobacteria. So anything that falls under this family is a good bacteria. Okay, so human research demonstrated that the consumption of whole grain products improves cognition. However, they found that studies indicates that elderly adults who consume red wine daily have improved cognitive performance, with benefits increasing in a dose-dependent manner, 75 to 100 ml. So this just means that if you drink about 1 cup a day, you're more likely protected. And this is actually different from males, females. Usually males are allowed, can take a little bit more. So you can say 100 ml is up to where males can take, and 75 ml is about where females can take. When you start consuming more than that, you're doing more harm than good. It's not that it's just neutral, it's the fact that you're actually doing more worse. Because what you want to know is that a wine also has alcohol in it, and alcohol is not good for the bacteria that are inside your gut. So you're going to be potentially harming those good bacteria, increasing the amount of bad bacteria that you're going to have, and thus promoting those bad diseases that we talked about, that the introduction was talking about in the beginning. So you don't want to be doing more than 100 ml per day. Another thing that they found that grape grapes were, or more specifically resveratrol, which is found in the skin of grapes, is able to produce, is that it's able to increase the abundance of short chain fatty acids, which are basically produced by the bacteria are that like to eat this resveratrol. So if you consume resveratrol, I think that's the isolated compound, the bacteria will break that down to and produce byproducts that are short chain fatty acids. And these short chain fatty acids are going to go and do further good things for your body. This identified that short chain fatty acids produce gut bacteria regulates microglia functions in vitro, that's outside the cell or outside the body, inhibiting immune induced production of pro inflammatory mediators, TNF alpha, IL-1, B, monocyte cream attractor protein, decrease the production of cytotoxic reactive oxygen species, and myelomonocytic HL60 cells, respectively, used as models of human microglia. So it seems that when you have resveratrol is produced, and then short chain fatty acids are the product of that. So they've done some animal models of Parkinson's disease, and we've seen here that 6-OHDA insult increases the survival of dopaminergic neurons in substantia nigra by 50% and results in a complete rescue of motor function of mice evaluated using the open field test. The accompanying in vitro investigation identified reduced neuronal apoptosis through inhibition of the caspase-3 pathway, downregulation of the pro-inflammatory nuclear factor B signaling, and decreasing reactive oxygen species production by dopaminergic neurons as a candidate mechanism responsible for the beneficial effects of this extract. Grapeseed extract exhibits several distinct neuroprotective properties. So the protective effects of the grapeseed extract are also observed in an in vitro rotenone-induced model of PD. Rotenone reduces the viability of human SHSYFY derived neuronal cells by 60% and upregulates the production of intracellular reactive oxygen species in these cells. Treatment with liposomes containing grapeseed and skin extract after rotenone administration restores the neuronal cell viability and reduces the intracellular reactive oxygen species production to control levels. Similar benefits are observed in 6-hydroxydopamine. Earlier here, I said that 6-OHDA insult. So 6-OHDA is a type of chemical that's usually put in mice to mimic the effects of Parkinson's disease within these mice. But what they did is they gave them grapeseed and skin extract before they gave them the 6-OHDA insult, which kind of increases we have that's how you have the survival of the dopaminergic neurons. So resveratrol induces neuronal autophagy, which is basically the thing that's found in grapes, through the activation of adenosine monophosphate activated protein. Studies establish that the activation of this pathway leads to the clearance of injured mitochondria and misfolded proteins, including amyloid beta and alpha synuclein, identifying a potential mechanism through which resveratrol may reduce neuroinflammation in AD and PD. So, oral administration of resveratrol for 15 weeks before the onset of amyloidosis leads to smaller amyloid beta plaques and less microglial activation compared to mice fed a diet not supplemented with resveratrol, reducing microglia mediated neuroinflammation and the deposition of amyloid beta plaques, along with decreasing oxidative damage and modifying apoptotic and neurotoxic processes, have been suggested as potential therapeutic strategies of AD and PD. So it's important to see here that when you administer for 15 weeks, this is going to reduce the formation of amyloid beta plaques. It's going to reduce microglia activation, and you're going to have the reduction of AB plaque deposition and neuroinflammation. So it seems that grapes have the capacity, or not grapes specifically, but there is virtual within grapes can cause that. So just don't look at this title here. This is kind of something that I put here so that I can kind of identify um, which main fruit this kind of chemical may be derived from. The next one here is pomegranate. Pomegranate is not well known to be it is known to be a good thing, but it's kind of, I think, usually like associated with older populations that will be drinking it. Um, so at the end here, this is kind of touching more on the resveratrol study, but they found that AB40 compared to the placebo group reported a similar stabilizing effect of AB40 as well as AB42 following the administration of resveratrol. So it's not necessarily decreasing it; it's kind of just bringing it to the lowest, to the levels that are kind of normal within the population. So it's kind of comparing them to the to the wild type version. of the populations that would be having these inside their brains. Treatment of resveratrol significantly reduces CSF levels of metalloproteinase 9, an indicator of BBB damage, and is associated with neuroinflammation. So this is very important to know that resveratrol kind of stops the breakdown of blood-brain barrier, and if the blood-brain barrier integrity is kind of intact, if there is further inflammation or upstream uh, death of neurons that causes a lot of inflammatory markers that are released, usually what happens is the immune cells that are outside the body will try to infiltrate the BBB because the cytokines are able to cross the blood-brain barrier. And if the immune cells detects this cytokines, it will try to cross the blood-brain barrier. And when they cross the blood-brain barrier, they will start increasing and increasing more inflammatory markers. And when it does that, that will cause more and more damage, essentially. So, in vitro study modeling the human gut microbiota finds that adding pomegranate powder to microbiome cultures beneficially alters the microbiota metabolism to increase the production of inhibitory neurotransmitter gamma and nucleic acid and a subset of certain fatty acids. So, it wasn't very common for pomegranate. There weren't a lot of studies about pomegranate and whether it had any beneficial effects, but it's just able to kind of increase this GABA, short chain fatty acids, and it was kind of not as the effect wasn't as popular as what not popular, but more, it wasn't as powerful as what the resveratrol was able to produce. So they found here that there was a significant increase in verbal memory when consuming this powder. Long-term retrievers scoring older adults with memory complaints who consume pomegranate juice for 28 days. No increase in this test score is observed in the placebo group. Functional magnetic resonance imaging demonstrate that subjects consuming pomegranate juice also display increase in basal ganglia thalamus, left inferior frontal gyrus, left middle frontal gyrus, left inferior temporal gyrus, left and right occipital lobes, left and right fusiform gyrus, and parahippocampal regions. So these are all memory and motor regions. So it's kind of important. And also ischemic stroke, it seems like pomegranate juice seems to have some sort of protective factor because ischemic strokes are a major risk factor of Alzheimer's disease. So it enhances cognitive functions following this type of events and it assists the prevention of degenerative disease. Neuroprotective effects of pomegranate products discussed in this section are summarized in table 2. So that was kind of summarized in the paper as well. The other thing that I want to talk about here is kefir. Kefir is a type of fermented food or yogurt. A study using the germ-free transgenic mouse of PD demonstrated that gut bacteria are necessary for the progression of alpha-synuclein-mediated brain pathology. This indicates that modulating the gut microbiota may be protective effect in Parkinson's disease. The most specific bacteria that seem to be in this study here are they're all like listed right here. So we have Actobacteria aceti, Actobacter sp, Lactobacillus delbrueckii, Lactobacillus fermentum, Lactobacillus fructobarans, Enterococcus faecium, Leuconostoc spp, L. kefira nullificans, Candida famata, and Candida krischei. Okay, so other studies demonstrate the beneficial effects of similar probiotic supplementation modulating neurocognitive outcomes. Consuming milk containing L. acidophilus, L. fermentum, Lactobacillus cassia, and bifidobacterium for 12 weeks resulted in significantly enhanced cognitive functions in AD patients as shown as 28%. Improvement in the mini mental status evaluation scores, so mini mental status evaluation, and which contrasts a decline in MMSE scores observing in the control group. So it just kind of increases it to a certain level. It doesn't necessarily remove the effects of that. So these are people who are kind of like showing some 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 medium to kind of mild symptoms of AD. So it doesn't seem to increase, it doesn't seem to increase the fact that their chances of reversing back to normal. It just would essentially be more like a band-aid, so it would reduce the amount of symptoms that they have. So there, this is shown by kind of increase in cognitive understanding and being able to memorize things and remember things better. So it's more of like a protective thing more than a treatment essentially. What I want to take note here from this paper is that damage to neurons correlates with the increased entry of peripheral leukocytes. Like I said earlier, when the BBB breaks down, leukocytes are immune cells. This results in activation of central nervous system immune cells, promoting further infiltration of effector T cells into the brain. Converting the gut microbiota to an enterotype that reduces the production of phenylalanine and isoleucine. Those are very bad proteins that kind of promote inflammation within the brain. leads to decreased proliferation of peripheral effector H1 cells, may be the one mechanism by which seaweed and its constituents such as sodium oligomerate. So this is not kefir anymore. Right now we're talking about seaweed. I will touch on kefir a little bit more actually. Let me get back to the paper here. So we have kefir. Okay. One thing that I wanted to touch on actually on pomegranate here is urolithin A. It's a bacterial metabolite which is produced from the illegitimins or basically the juices of pomegranate. This has been shown to have neuroprotective effects in vivo. So, study using APP-PS1 transgenic AD model mice demonstrates that daily oral administration of this improves learning and memory in some cases, restoring the parameters measured by the Morse Watermeters test. So these are all mouse studies. Just I didn't really add them in the presentation because it was not a human trial. They weren't human trials, but it's just something to take note of. So urolithin A is a metabolite of pomegranate juice. Not a lot of consumption, so not a lot of studies of pomegranate were found for humans, but the one that was found here, healthy male age and older adults, reveals that the consumption of pomegranate juice helps preserve memory function. But these are healthy adults, these are not people who have Alzheimer's disease. So I didn't really think that I should add that there either. But something else that I should take into note is that beneficial effects should be considered when designing neuroprotective dietary interventions. So if you want to kind of prevent this disease, it's important to kind of take into account that pomegranate juice is good for you. There you go. And then when we talk about kefir, there's further things that I wanted to touch on here. So we know the bacteria that have to be inoculated within the kefir in order to help it do what it does. So these are the ones that I touched on earlier. And here we see that a study using germ-free transgenic mice model of PD demonstrated that gut bacteria are necessary for the progression of alpha-synuclein, mediating brain pathology, so which indicates that modulating the gut microbiota may have protective effects in PD. That's what I was trying to touch on earlier. So this minimizes the risk of degenerative disease. How does it do this? So this is known to be anti-allergic and anti-inflammatory. Risk factor of degenerative disease is associated with oxidative stress, which also directly contributes to the AD and PD. So aging is the most considerable risk factor of neurodegenerative diseases, which is modulated by oxidative stress. And we have kefir, which is known to be very high in antioxidant potential. So what it will do is it will essentially reduce this oxidation that occurs. How? A novel kefir grain product containing Lactobacillus kefiri, L-kefiri, Kazakhstania turicensis, Kazakhstania unispora, and Chloeveromyces marexanus. This reverses age-associated oxidative stress. After 6 weeks of supplementing the diet with PFT, oxygen radical formation is inhibited. Glutathione stimulating hormone and total antioxidant capacity is increased, whereas nitric oxide and MDA levels are reduced, demonstrating a reversal of age-associated oxidative changes. Okay. We also have the same study also described improved morphology of the intestinal barrier and reduction of the pro-inflammatory cytokines TNF alpha, IL-6 in the hypothalamic paraventricular nucleus, and rostroventrolateral medulla, whereas the brain directly below the pathogenesis of hypertension. This fermented beverage has favorable effects in insulin metabolism, serum levels of triglycerides, MDA, and CRP, indicating improved energy metabolism and decreased oxidative stress and inflammation. The neuroprotective effects of kefir discussed in this section are summarized in Table 3. Yeah. So here's the table. You have the animal, 10-month-old Swiss albino mice, daily oral administration of, we can look at this table better. So daily oral administration of PFT, and you can see this is reversed age-associated oxidative changes demonstrated by inhibited oxygen species, reduced nitric oxide, MDA levels, increases JSH, total antioxidant capacity, and anti-hydroxyl radical content. So a lot of effects were coming from consuming this product. So it's kind of important for you to it's important to see this, but there's not a lot of human studies. So kefir is not something that I want to touch too much on. But what I wanted to go further on is seaweed, which has it's got some very interesting things that I want to touch on here. So seaweed, excuse me, we have fluorotannin. Fluorotannin containing fraction inhibits over 90% of AB aggregates. What is this fraction they're talking about? So we have seaweed is basically like a type of algae, and within this algae there is a brown alga. So let's start. So study investigating the neuroprotective activity of various fractions of extract from Eclonia radiata, which is a type of seaweed, specifically brown alga, reports that of this extraction tested, the one containing the highest concentration of fluorotannin inhibited 90% of formation of amyloid beta. So I'm going to take note of. Another specific thing that I want to talk about is GV971, which is a derivative of seaweed. Sodium oligo, or so known as sodium oligomanate, is another carbohydrate found in brown algae that has been used to develop an anti-AD drug. This drug has been seen to modulate gut microbiota to decrease neuroinflammation. So these are mice that are engineered to have Alzheimer's disease from a very early age, usually familial Alzheimer's disease, which is kind of the most dangerous type of Alzheimer's disease that affects people from a very, very early age. And so APB, PS1 mouse models. The oral administration of GV971 once a day for 3 months significantly improved cognitive functions of APP pre-Cellin 1 mice, as shown by improvements in various spatial learning and memory performance scores in the Morris watermelon taste. Just to take into account, this drug, GV971, has been approved in China to help people who have mild to moderate Alzheimer's disease. So compared to untreated mice, GV971 administration also alters the composition of gut microbiota communities, inhibits infiltration of peripheral Th1 cells in the brain, reduces microglia activation, modifies brain cytokine levels, and decreases AB plaque deposition and tau, phosphorylation in the brains of APPPS1 AD mice. To determine the possible mechanism throughout which GV971 inhibits neuroinflammation or fecal metabolome, these studies have been conducted which reveal significant alteration in amino acid metabolism. So we have phenylalanine and isoleucine again showing up in this. So these proteins seem to be very important. Not proteins, sorry, these amino acids seem to be very important in the accumulation of these plaques. So you see a lot of these amino acids within the lumen or the brain of the people who are affected with these amyloid beta plaques. So fecal and blood concentration of phenylalanine and isoleucine are substantially elevated in untreated AD mice. Okay, GV971 administration significantly reduces the concentration of these amino acids to those similar of wild type mice. Wild type mice are kind of mice that are just normal and don't have this kind of lineage of familial ID. So they weren't engineered to have Alzheimer's disease. They're just normal mice. So GV971 treated AD mice and to untreated wild type mice, which are subsequently intraventrically administered aggregated AB, decreasing Th1 cells in the brain of recipient mice is observed, demonstrating that the feces of GV971 treated AD mice effectively substitute, meaning giving them the oral method might be even better than giving them giving them the anal method. So basically, taking the feces and then implanting the feces into the uh, the the uh, the mice that weren't given the GV971 is a more effective method of treating the Alzheimer's disease on the control mice that had Alzheimer's disease but didn't receive the drug, as opposed to giving them oral administration of the drug. Co-administration of antibiotics abolishes these effects, meaning if you give them the drug, any antibiotic, and GV971 is inside their gut, it will be destroyed, and thus the therapeutic actions will be destroyed as well. So GV971 is what I wanted to touch on in this specific study. As furthermore, this has been shown to go to phase 3 clinical trials, and this is demonstrated by statistically significant 2.14 point difference between the treatment and placebo groups in change from baseline after 36 weeks of treatment, going to the 12-item cognitive subscale of the Alzheimer's disease assessment scale. The drug placebo difference in ADAS COG-12 scores increases with duration of treatment and severity of cognitive decline. Additional research is required to identify the GV971 mechanisms of action. This trial demonstrates improvements in clinical scores, whereas non-clinical studies provide evidence of disease-modifying mechanistic action of GV971, illustrating the potential of this drug to ameliorate symptoms and slow the progression of AD. GV971 has also been approved for clinical use in China to improve cognitive functions in mild to moderate AD. So at least it doesn't seem to have a lot of drawbacks, because a lot of the drugs that exist now tend to kind of come with a lot of side effects for the people who take them. So it's good to see that there's a drug here that's available that may not be able to treat the severe Alzheimer's disease, but at least may be able to attenuate those mild to moderate symptoms of Alzheimer's disease and reduce the amount of side effects that may come with that, with taking the drug. So that looks like the end of the slide. Thanks for watching, and I hope y'all have a great day. Bye.